In this video, we're going to practice simplifying radical expressions. So let's remember that for a radical expression to be simplified, all of the following need to be true. The radicand can't have any perfect square factors other than 1 in it. The radicand cannot contain a fraction. And the denominator, if it's a fraction, cannot contain a radical expression. Before we actually do any examples, I just wanted to show you this list of perfect square roots, really most of which you should already have memorized. Keeping these perfect square roots in mind are going to make simplifying radical expressions a lot easier. So as we know, the square root of 1 is 1, the square root of 4 is 2, root 9 is 3, root 16 is 4, etc. You may not have some of the ones at the bottom of this list memorized, so if there are any of these that you want to copy down for yourself, maybe the last couple, you're certainly welcome to, just so you can keep an eye out for them. Keeping these perfect square factors in mind is going to make simplifying radical expressions a lot easier. Please write for yourself simplifying square roots. We're going to talk briefly about how to do it and then do some examples of simplifying square roots. So what we're going to do in order to simplify square roots is break down the radicand into perfect square factors. Then we're going to simplify whatever is able to be simplified. You can take a moment to write that down. You don't have to write what I have handwritten here in green, but I just wanted to point out that really when we're breaking down the radicand into perfect square factors, we're looking to factor out the largest perfect square factor that we can. That's going to make your life a lot easier to look for the largest perfect square that is a factor of your radicand. These are the 3 examples that we're going to do together right now. So first, write for yourself example 1. We're going to simplify root 18, or the square root of 18. So when we're simplifying radical 18, we just have to think to ourselves, what is the largest perfect square factor of 18? So if we think back to that last slide where we looked at all of those perfect square roots, the largest number from that list that's a factor of 18 is 9. We know that 18 is 9 times 2. So I'm going to rewrite root 18 as root 9 times root 2. Root 9 simplifies to 3, so I'll write that as 3. I don't have any way to simplify root 2, so I'm just going to rewrite the root 2. That right there is my simplified radical expression. Now I know that 3 root 2 might look a little more complicated than root 18, but what we care about is that all 3 of the criteria on the first slide we saw today are true here. So we see that a radicand of 2 doesn't have any perfect square factors greater than 1 in it. So that is the simplified form of root 18. It's 3 root 2. Go ahead and copy number 2. We're going to simplify radical 48. You might have to think a little bit harder for this one to figure out what the largest perfect square factor of 48 is. It's actually 16. Because 48 equals 16 times 3, so root 48 equals root 16 times root 3. The square root of 16 we know is 4, so we'll go ahead and simplify that portion. And that root 3 can't be simplified anymore, so I'll just rewrite it, which gives us that the simplified form of root 48 is 4 root 3. I just want to take a moment to point out, before moving on to number 3, that if you hadn't realized 16 was a factor of 48, you still could have simplified this. I wrote separate work out. Let's say you had only noticed that 4 was a perfect square factor of 48, and you wrote root 48 as root 4 times root 12. We know that the square root of 4 is 2, and then we have this root 12 here. However, we then have to make sure that there's no perfect square factors within 12. 12 still has a factor of 4. So you can see in the next step of my work, I rewrote root 12 as root 4 times root 3. I then simplified root 4 because that's really 2. The square root of 4 is 2. And now I have 2 times root 3. 2 times 2 is 4. So my answer here is 4 root 3. So you can see that I got the same answer as I did earlier. I had a few extra steps. And really, we have to be careful because some students will leave this as 2 root 12. They'll just simplify this, and then they won't double check their final answer to make sure that it's simplified. So either be really careful to make sure you factored out the largest perfect square factor of your radicand, and or double check to make sure that your final answer is completely simplified. Please copy example 3 if you didn't do so yet. In example 3, we're simplifying the square root of 72, or root 72. The largest perfect square factor of 72, this is another one. Maybe the first thing you would think is 9, but it also has a perfect square factor of 36. So the fastest way to do this is to recognize that 72 is 36 times 2, so root 72 is root 36 times root 2, which the root 36 will simplify to 6, and we still have that root 2 there. So our final simplified answer for number 3 is 6 root 2. Our next example is to simplify the square root of 4/3, so I'll give you a moment to write that example down. I already have my work for this example written out here, but I'll explain it as I go along. So we know that the square root of 4/3 is not simplified because we said earlier we can't have a fraction within the radicand. The first thing we're going to do to simplify this is to rewrite that square root of 4/3 as the square root of 4 over the square root of 3. So we are rewriting that single radical as a quotient, as root 4 over root 3. At this point, we know that the square root of 4 is 2, so we're simplifying the numerator. Instead of writing it as root 4, we are writing it as 2. But now we see that we have a radical expression in our denominator, which we know is not allowed for simplified radical expression. So we need to get that radical out of the denominator. In order to do so, we're going to multiply by something that is going to get the radical out of our denominator. It's actually called rationalizing the denominator. What we're going to multiply by is root 3 over root 3. We chose root 3 because we know that if we multiply the root 3 in the denominator by root 3, we'll get root 9, and we know that the square root of 9 is 3. So multiplying root 3 by root 3 will wind up taking the radical out of our denominator, or in other words, rationalizing the denominator in order to help us simplify this radical expression. Let's keep in mind that anything you multiply the denominator of a fraction by, you also need to multiply the numerator by in order to keep the same value of that number. Really, multiplying by root 3 over root 3, or multiplying by anything over itself, is the same as multiplying by 1. So multiplying by root 3 over root 3 is not going to change the number that we have, but it will help us to simplify by rationalizing the denominator, or in other words, by getting this radical out of the denominator. So when we multiply by root 3 over root 3, 2 times root 3 is just 2 root 3. Root 3 times root 3 we said is root 9, which when we simplify that gives us 3. Technically, this step right here you don't necessarily need to have. If you feel comfortable going straight from this step to this step, I'm okay with that. So we wind up with a final answer of 2 root 3 over 3. Again, you might think that that looks less simplified than the original expression of root 4/3 that we had there. However, we need to remember the 3 criteria that need to be true in order for a radical expression to be in simplest form. We see here our radicand doesn't have any perfect square factors greater than 1. 3 doesn't have any perfect square factors in it other than 1. We see that we do not have a radical in the, we do not have a fraction in the radical symbol, and we do not have a radical in the denominator of the fraction. So this is the simplified radical expression of the square root of 4/3. This is the last slide of this video. I'll give you a moment to copy these examples. We're going to start by simplifying root 2 times root 8, and then we're going to simplify the square root of 294 divided by root 3. We're going to follow these steps here for each of these 2 examples. You don't necessarily need to write them. You certainly can if you want to, but I sort of color-coded everything so you can see what step I'm at each point. So for my first example, I'm starting with the problem, root 2 times root 8. I'm going to write both numbers under one radical, so that equals the square root of 2 times 8. Now I'm going to simplify the expression under that radical, so I know that 2 times 8 is 16, so that equals the square root of 16. And then I'll factor out perfect squares and simplify. So we know that the square root of 16 is 4, so that's my final answer here, 4. Now we're going to do our other example on the slide, root 294 divided by root 3. I'm going to follow the same steps. So first, I am going to write both numbers under one radical. So I'm going to rewrite this as the square root of 294 over 3. Next, I'm going to simplify the expression under the radical. So if you take 294 and divide by 3, that will give you 98. And I will factor out any perfect squares and simplify. 98 itself is not a perfect square, but it has a factor of 49 in it, so I'm going to rewrite root 98 as root 49 times 2. We already know that the square root of 49 is 7, so our final simplified expression here is 7 root 2.